Good morning, Abhilasha ma'am.
Good morning, ma'am.
How are you?
Good morning, ma'am. Am I audible to you?
Yes, ma'am. You are audible, and students are joining. We'll just wait for next 5 minutes. Okay,
Sure. No problem. Yes.
ma'am. Will you be able to stop your share? I wanted to share one screen, and then you can start the share.
Sure.
Thank you, ma'am. Students, tell your friends to join fast. तुम्ही केला नाश्ता? I think my screen is not visible.
No, ma'am, it's not visible. It's blank. Yeah, now it is visible.
Now it's visible. Thank you. Chalo. Isha, Tanvi, please tell your friends to join fast, so that
Yes,
man
ma'am.
can so man can cover maximum things. Actually, we got lectures till 10:30 and 11. So
Fine.
maybe now they will finish it off and join here soon.
Sure, ma'am.
Neetu madam, can we start? Just let our in charge principal ma'am to join, huh, ma'am?
Yes, ma'am.
Otherwise, I'm ready.
I've joined.
Yeah, thank you, ma'am. Ma'am, can we start? Neetu ma'am, can we start?
Yes, Pooja madam, you can join.
Yeah, I'll join. Can we start?
I
Can we
start. Sorry.
Yeah.
Start.
Thank you, miss. So good morning, everyone. I, Assistant Professor Pooja Oak from Department of Management Studies, heartily welcome today's resource person, Professor Abhilasha N. Madam, from Mulund College of Commerce, in charge principal madam, staff secretary madam, all the teaching, non-teaching staff, and the research aspirants. Feels good, na, when somebody calls you a researcher? Research is to see what everybody else seen and to think what nobody else has thought of. Research is the distance between idea and its realization. Research is this and research is that. More we do the research, we feel to express it. It's indeed an intellectual activity. BMS has a subject, research methodology, in semester 4. To know more about it, grab the knowledge from the expertise. Today, management cell has organized a session on research methodology for the students. For this session, we have a very perfect guest, Professor Abhilasha N. Madam. She will guide you on different data analysis tests and research from the student's point of view. Let's know more about her. Professor Abhilasha N. He's completed MCom, MPhil, SET, and pursuing PhD in Commerce from Indira Gandhi University, IGNOU, Delhi. She has experience of 6 years in teaching. She has presented 17 research papers, out of which 16 has been presented by her. She's attended more than 45 workshops, FDPs, and conferences. She has guided more than 72 research projects. She is the member of editorial board. She is the resource person of the topic research methodology, statistics, techniques, and UGC NET exams in the various colleges. She has got Best Research Paper Award in 2020 for accounting, Best Teacher Award for 2019, and Best Researcher Award for 2022. Congratulations, madam, for all those awards. And now, going ahead, Management Cell of Bharat College is continuously engaged in innovative activities for the students' progression. Our young, dynamic in-charge principal, Dr. Neetu Kapoor, always inspire us and motivate us for such activities. In spite of n number of responsibilities, she always stands behind us for each and every activity. I request Neetu madam to say a few words. Neetu madam, over to you.
Hello, very good morning, one and all. I take this privilege to welcome today's resource person, Miss Abhilasha from Mulund College of Commerce. Ma'am, it's really a privilege having you with us on a topic which is always green, always young, like you. Always,
Thank you.
always the topic which attracts the interest of the researchers, research scholars, or social scientists in the field of social sciences. I think ma'am would be the apt personality for the day to talk more on research, why we do research. Basically, what is the role of a researcher is to discover an unknown fact about something, to, to reach from a known to an unknown part of any activity. That is what is research. Search and then again research to find something new into it is research. And when we do research, we do testing, we do statistical analysis, we collect data. There are activities there are n number of activities which will give us the findings or the final results. This is a process. It's not a 1 day or 1 hour game. It's a process and a very long process. All my students are enthusiastic taking up a research project for Avishkar. And I think today you'll get a very right way, or you'll be enlightened on the right part by Abhilasha madam on how to go about for research. How do you select your topics? How do you do analysis and all, and so on. So I welcome you, ma'am, once again on this online platform for guiding our
Thank you
students.
so much.
Ma'am, not only students, we are also there as today's learners to this session. So ma'am, most welcome. And I request students, please take a pen and a book. Just don't listen. What you feel that it is important, please write it down, note it down, so that it can work as a reference material for you whenever you go ahead with your research work. So with this, I thank Pooja madam for organizing this activity. I'm always keenly interested in anything on research, so I'm very thankful to Pooja madam. I'm thankful to all the participants for joining it. See that the interest that you have generated at the beginning of this session, it lasts till the end of the session. You keep on writing the notes. You can put your doubts on the chat box so that ma'am can answer at the end of the session. Thank you very much once again, and ma'am, over to you. Pooja ma'am, please take over the charge and let's continue.
Thank you, ma'am. Thank you so much. So, Abhilasha ma'am, I wanted to tell you that since last 2 years, our research project are getting selected in the first round for Avishkar. This year also students have participated. Our 4 groups are there from our college and they all are there for the session. So over to you, ma'am. Please guide my students with your knowledge. Thanks a lot. Over to you.
Thank you. Thank you, ma'am.
Pooja ma'am, can you mute all other than madam? Can you please mute everyone?
Yes.
Thank you, Neetu ma'am and Pooja ma'am for giving such a wonderful platform to share my knowledge about research methodology. Ma'am, can you stop sharing the screen?
अभिलाषा मैम, मैं सबको अनम्यूट कर रही हूँ, आपको वापस एक बार म्यूट करना पड़ेगा बस.
Sure.
Just ताकि आपको कोई डिस्टर्बेंस ना हो. Just give me a second. Now you can do, ma'am.
Yes, ma'am. Thank you. And a small request to all the participants, please keep yourself. I can give best of my knowledge. And also, whenever you have a doubt, you can just drop a message in the chat box. I'll be seeing the chat box frequently. Okay, so
मैम आपका आवाज थोड़ा लो है.
Am I audible now?
Yes.
Yes, a kind request to everyone. So to keep yourselves mute. So whenever you have doubt, you can just drop a message in chat box. So I'll be seeing the chat box frequently. Fine. So we'll start the session now. Yes. So as Madam has already given a wonderful introduction about myself. So let us not waste our time by just understanding your resource person. So we'll go what are the content that I'm going to cover. So actually I have given a limited time, 1 hour, where I need to cover some good number of topics. So I'll try to give justification by covering everything in a very precise and clear way. And I'm getting some disturbance from somebody here.
Yeah, मैम आपका आवाज अभी भी थोड़ा लो आ रहा है.
Ma'am, you can just ask other participants. Actually, even my students are attending. They are telling it is correct.
अच्छा, okay, just a minute.
Fine, sir. Yes, students, if you get any issues from my side, you can just drop a chat box message. I'll be taking care about any technical issues. Fine. So this is a topic for today. So introduction of research. So this I'm not going in detail because already I've learned about all these things in your graduation. So my focus will be on hypothesis, chi-square, t-test, z-test, f-test, ANOVA, and also the 2-tail and 1-tail test. Okay, let's begin with the introduction. So as I told you, I won't go into theory in detail. So I'll just give a quick recap of all the important theoretical perspectives. So then we'll proceed with the practical. So I'll be sharing this PPT, and I'll also be sharing some the important material which I've prepared exclusive for you. So you can just concentrate more than writing. I want you to listen carefully, and any doubt you can just drop a message in chat box also. So in simple words, so as you know, research is nothing but searching again and again to give solution for the problem or to add something for existing knowledge or to solve the problem of any societies or for any the academic issues. Okay, this is about the simple meaning of research. So for example, when we got this pandemic situation, so finding that vaccine, even that is one of the research that we have ended. Okay, so this is about the meaning. So again, I'm not going in detail regarding all theories and why the research is needed. These are the three main of theory in the academic or for society. We are going to do a research. Best example is Newton's law or any motivation theory that you learn in your business management, like Maslow's theory, Herzberg theory, McGregor's theory. So all these are theoretical research. Next is factual, to find new facts and figures. So as you know, the government is going to conduct survey or census every year to know what the total number of population, how many people got affected with the COVID, how many got recovered. So it is called as factual research, where they're going to derive the result by using some data. Next is application. So it is a use of existing theory for newer situation. Okay, already the Maslow's theory is there that you're going to adopt for your organization or for your college. Okay, that is about application. So whatever the theory is already there, that I'm trying to implement for the current situation. This is called as application research. So these are the three main important objectives of any kind of research that we do. Okay, so next is different types of research. So just I'll give a brief view on all these points. So first one is action research. So whenever there is a issues in the lower level, I mean the issues is less impact. So there we are going to apply the action research. You can see the meaning here, to solve immediate solution. Okay, so any problem which needs an immediate solution, we are going to apply the action research. Okay, for example, in the college, some issues are going on. So in this case, the principal has to take an immediate action to resolve that issues which is going on in the college. So it needs some immediate attention. That is called as action research. Next is fundamental, pure or basic research. Okay, this is a research where we do for the sake of knowledge. Okay, for example, as everyone knows about the GST in the year 2017. Being a commerce graduate, we should know something about the GST. Okay, if you start extracting the information from different sources just to enhance your knowledge, that is called as fundamental research. Okay, so next is applied research. Okay, so whenever it is an economic problem, it's not the small issues, it's the bigger issues. Okay, then we are going to apply applied research. Okay, so you can see here, principle made by fundamental research, application of concepts and practical concepts. So whatever the theory that we have developed in the basic research, that we're going to apply in the applied research. Okay, by giving solution for the bigger issues. Okay, for example, the employees in the organization, they're not getting enough motivation to work better. So obviously it's a big issue for the company, because when the employees are motivated, then only they can give best out of their capacities. So here I'm going to adopt any of the motivation techniques in order to motivate my employees to give more productivity. So your applied research applicable for some bigger issues, whereas action research related to some smaller issues. Okay, this is about some of the types. And empirical research. So if you want to know some what practical relevance of any issues, okay, for example, how this COVID is having any the relationship with the co-vaccine or COVID. So there is some rumors, even after taking this COVID vaccine, people are getting infected. So now I'm interested to know what is the relevance of that COVID or the Covishield with respect to the reduction of COVID cases. So I can do the empirical study. And cross-sectional, so majority of your research will be the cross-sectional, okay, where you're going to take 1 year company, one company, where for 1 year for different company. Okay, for example, I'm taking 10 years of only one company. Okay, for example, Infosys company. So I'm interested to know whether Infosys company, ma'am, I'm getting some noise again. Savita. Yes. So in a cross-sectional study, we are going to take one company for several years. For example, I'm interested to know how Infosys company is performing from last 10 years. So here I'm going to see the 10 years annual report of only one company, that is called as cross-sectional. And opposite is longitudinal. Okay, I wanted to invest on best company. So I'll take 10 companies and I'll try to analyze their recent annual report. So I'm taking one company one company for different years. Okay, so that is called a longitudinal. You can see here different years, but the company is only one. Co-company, I'm analyzing their 4 years annual report. Okay, to know whether they're performing better or not. Next is descriptive. Okay, when you start explaining why it has happened, when it was happened, what's the consequences, what's the pros, what are the cons. So when you start describing any given phenomena, it is called a descriptive research. Next is analytical. Okay, so here it explains how it has occurred and to build some causal relationship. For example, if I increase my advertisement cost, okay, how it is going to increase my sales. Okay, here I'm going to analyze the cause and effect relationship between two variables. Okay, after attending this webinar, so what kind of statistical knowledge that you got increased? Okay, analytical research. And the last one is export factor research. Okay, here the research will be done after the incident. After the incident has been happened. For example, the accident has happened. Okay, now I am doing a research. Okay, so what made the accident to be occurred, and what are the situation and where it was happened, and who met with an accident, their background. So when the fact is already done, if you are doing a research, it is called as ex post facto research. Okay, or else we can take one more example. So already we are facing this pandemic situation because of COVID. So now I am going to study the impact of COVID on students, the impact of COVID on the business. So whenever the situation has happened, then if you are trying to do some kind of research, it is called as ex post facto research. Okay, so these are some of the types. Even this you might have learned in your graduations. Very, very important. So the ethical issues with respect to research. So in research, there will be chances where we'll do some unethical issues in order to do our research work in a very shorter span. Okay, these are the three important types of unethical issues that may arises when you're doing a research. Okay, first one is falsification. Okay, it means you're changing a data. Okay, for example, you're studying about the impact of COVID on students, and you're given a question here, and you wanted to have that positive result. Okay, so what to do? Whoever said yes, you're making no, and whoever is telling no, you're making yes. Okay, I'm giving a feedback link for you. Okay, like are you satisfied with the webinar? Okay, maximum said no, and few students said yes. So just to have that good impression, I'm manipulating the things. Okay, whoever said yes, I'm making no, and whoever is telling no, I'm making yes. Okay, so when you're changing the data purposefully, that is called as falsification. This is unethical. We should not do. Next is fabrication. You're creating data. Okay, for example, there are 50 plus students in the class. Okay, so I wanted a response from all 50, but unfortunately, only 10 students have given feedback. So what I'll do, another 40 responses, I am going to fill by myself. filling the questionnaire. Even that is wrong. That is called as fabrication. You are creating yourself in order to have some good sample. Next is plagiarism. This is one of the biggest unethical things that is done in the research area. Okay, you're copying somebody's work without giving any reference. Okay, for example, as you know, one of the author of the marketing, Philip Kotler. Okay, so Philip Kotler has written the textbook of marketing. So I'll be copying same thing and I'm publishing with my own name without giving acknowledgement, without giving reference, without saying thanks for that person. Okay, that is called as plagiarism. Okay, so copying data without giving references, it is called as plagiarism. It is unethical thing. And we do have some software in order to find out in what way and what percentage from where you're copied, we can figure out by using a particular software. Okay, this is about research ethics. This is a particular stuff. This is steps of doing a systematic research. So first, you need to identify the research problem. Okay, next you need to do some review of literature. A review of literature means in order to find out the research gap, what is already been covered and what you need to cover. So that idea you will get by reading some of the previous literature. That is called as review of literature. Developing an hypothesis. So hypothesis we are going to study in detail. I'll come back to this. And research design is a blueprint. Okay, as you know, for doing any kind of work systematically, we need planning. Okay, without planning, you cannot complete your task on time. So your research design means that the blueprint of your research or the pre-plan that you made in order to complete your research on time. Next is data collection. So there are two important data collection, primary data and secondary data. Okay, primary data means you are collecting for the first time. Okay, you won't get that kind of data anywhere. You need to prepare a questionnaire, you need to circulate among the responses, and that is called as a fresh data. That is called as raw data. And second data means the data which is already available in different sources. It may be a textbook, it may be a website like SEBI or RBI or moneycontrol.com. So whenever the data is already available, it is called as secondary data. Okay. Next is data analysis and interpretation. So whatever we get data that we are going to analyze by using some statistical tool. Okay, this I am going to focus more for today's session. And finding and conclusion based on the results, we are going to give conclusion. Okay, that is a statistical conclusion we are going to draw. Okay, even this I'm going to discuss today. And finally, the report writing. Okay, there's a particular format that we need to follow in order to write your research paper. Okay, even that I'll be just showing the steps. Okay, I'm not going in detail regarding that particular concept. So as we already discussed, research design is the blueprint of your research work. Okay, this is very clear and very important is sampling. Okay, obviously, if I wanted to know how many people got affected with this COVID, okay, it is very difficult to cover all India. Okay, and even very difficult to cover the Mumbai also. Okay, so what I'll do, so I'll select few people from all population. Okay, there are 50 students. I wanted to ask the feedback. It is very difficult to ask the feedback of all 50 because of time constraints. So what I'll do, I'll select 5 people randomly. Okay, that 5 people which I took randomly, they are called as sample. Okay, and all 58 students who are the part of this webinar, they are called as population. Okay, the part of population is called as sample. Okay, so this is about the simple meaning of population and sample. So population means the whole the universe, and due to time constraint and due to the different reason, it is very important to cover all the people who are in the part of society. So I'll take a few samples from this population. They are called as sample. Okay, so as you're picking few samples from this whole population, there's a technique in order to draw a few people from the sample. So you can see here, there are 5 people and let us assume that there are 50 people here. So how you're drawing these 5 people? There's a logic, there's a reason, there's a particular step procedures we need to follow in order to pick that 5 people from this whole population. Okay, that is called a sampling technique. You can see the meaning here. Technique used to draw a sample from the population. Okay, the technique, how you are drawing this 5 members from this whole population, it is called a sampling technique. Okay, again, there are 2 types, probability and non-probability. Probability means I'm giving equal chances. Okay, best method is lottery method. So there are 58 students. So I'll write everyone names in a particular set. I'll pick randomly a 10 set. So whoever the name is written, they'll be my sample. Okay, so I'm giving equal chance for all my students here. That is called as probability. And non-probability means as per my convenient, I'm going to pick the students. So as you know, usually in a class, only the first 2 benches will be very active in some of the classes. So as they're active, I'll just take feedback from only that first bench students. I'm not giving equal chance here. Or if some students are very close to me. So I just ask the opinion about the webinar with my students itself. How was my webinar? Obviously, as they're close to me, obviously they'll be giving positive opinion. Okay, here I'm not giving equal chance for all the population here. Okay, so your probability means giving equal chance, non-probability means not giving equal chance. So again, there are different types here. So let us first discuss about non-probability. Non-probability means where equal chance is not given. Okay, first one is convenient. So as per your convenient, you are collecting data. Okay, so few students stays near my locality, so I'll just go there and I'll collect the data. Okay, and due to the social media, so everything will get in our fingertip. So as I'm having various WhatsApp group, so I'll just put that questionnaire in my WhatsApp group and I'll request all my students to fill out. So without putting much efforts, I'm collecting data here. That is called as convenient. Next is judgment sampling. Okay, I'm having a criteria. I'm going to analyze the impact of this class only on the females, I mean the girls. Okay, so here I'm keeping some criteria here. So the questionnaire, whoever is filling, they should be female. Okay, I'm putting some criteria. That is called as judgment. Okay, so here it is also called as expert sampling. Samples are selected on the basis of judgment. I am judging based on the gender, and if they are female, I'll be giving a questionnaire to them. Okay, or else I'm targeting only with the age group of more than 25 years. So I'll just ask their age. Are you above 25 years? If they say yes, then only I'm going to give questionnaire. Otherwise, I won't take them as a sample. So next is quota sampling. So this you might have experience in our college days also. So when it's come to admission, they'll give some quotas: SC, ST quota, general quota, OBC quota, and EVS quota. Okay, so that is about quota sampling. That's a simple meaning. And snowball sampling, very interesting. Okay, here the sample will be collected through references. Okay, I am doing a research on the severity of COVID patients in Mumbai. Okay, obviously I cannot get a data who got affected with the COVID. So what I'll do, I'll go to the doctor who is treating a COVID. Okay, and that doctor is going to give the patient who got affected with the COVID. Okay, I got the data. Again, that doctor is going to give reference of another doctor who is treating a COVID. Again, I'll go to the second doctor. He's going to give some sample. Again, the second doctor is going to give third doctor name. Okay, I'll go with the third doctor. Again, giving some samples. Again, third doctor is going to give fourth doctor. So whenever you collect the data with a series of references, it is called as snowball sampling. Okay, so while teaching, if you had any sort of doubt, so kindly drop a message in the chat box. So next is probability sampling. So again, very interesting topic. So simple random sampling. So you're selecting a sample randomly. Okay, for example, lottery method. Okay, or else randomly there are 56 students. Randomly, I'll call some name like number 2, number 7, number 11, number 20, number 45. So randomly I'm picking some number. That is called a simple random. And second one is systematic random sampling. Here every n item will be selected for sample. Okay, for example, roll number 1, roll number 10, roll number 20, roll number 30, roll number 40, so on. Okay, here I'm giving us some equal distance here. You can take any number. You can take 5, 15, 25, 35 like that. Or 1, 11, 21, 31, 41 like that. So whenever every nth item is selected for sample, it is called a systematic random sampling. Okay. So next is stratified. This too, usually student will get confused, but it's very simple concept. So in stratified sampling, let me explain through an example. Okay, this you have understood. Simple random. So randomly I'm picking some people for my study. In a systematic sample, you can see here every second item I'm selecting. First person, again leaving 2 gap, third person, again leaving 2 gap, third person, again 2 gap, fourth and fifth. Next is stratified sampling. Please listen carefully. This is quite important and also confusing also. Okay, so here the whole population will be divided into different groups. Okay, for example, there are 5 departments in your college. Okay, like BCom, BBM, BSc, CS, and IT. Okay, for here the whole college, so whole Bharat College has been divided into 5 different groups or 5 different departments. From each department, I'm picking 20 students. Okay, that is called as stratified sampling. You can see here, this is a 4 department. Let us assume that this is your college. Okay, your college has been divided into 4 different departments: BCom, BBM, BMS, and IT. Okay, from each group, I'm selecting some sample randomly. Okay, this is called as stratified sampling. And also remember, okay, all groups are not same here. Okay, BCom is different, BBM is different, BSc is different, and BMS is different. So your stratified sample is called as heterogeneous in nature. Heterogeneous means samples are different. Okay, because all students not from same department. I have taken from different department. So remember, stratified sampling means all group will be divided into different groups. From each group, you are going to pick few sample randomly, and that groups are heterogeneous in nature. Heterogeneous means different. In the cluster, here also the Bharat College are divided into 5 groups, 5 departments. Okay, where I'm going to select 2 groups directly. Okay, it's a BCom, BBM, BSc, CS, and IT. Okay, instead of selecting few from every group, I'm selecting directly BMS and IT directly. Okay, this is called as homogeneous nature. So I can select only one group also. Okay, instead of selecting 2 groups, I can select one group also. So here all the student belongs to that particular class, they are same. So it is called as homogeneous in nature. Okay, few difference here. Okay, here the population will be divided into different groups. From each group, you are going to pick few samples. Okay, and that groups are heterogeneous. Whereas in cluster sample, here also you are going to divide the whole group into whole population into different groups, where directly some groups are selected. Okay, so that group will be homogeneous in nature. Okay, this is a very important concept. You even some of the researcher will get confused with respect to stratified and cluster. And for PhD entrance exam and for your degree exam, at least one question you'll get from this component, either the stratified or cluster. Usually they'll try to keep stratified sampling is of dash nature. It is heterogeneous in nature. Okay, and cluster sample is of dash nature. It is homogeneous in nature. Okay, homogeneous means same. Heterogeneous means different. I hope it is very clear for you. If you get any sort of doubt, feel free to drop a message in the chat box. So again, this I already explained, source of data collection, primary and secondary. So again, I'm not going. 1 second, I'm getting some message. Yes, fine. So this is about the format of research report. So in your TY BMS, you'll be having a project and you need to follow a particular format in order to have a systematic flow of your research information. And also for doing your PhD or MPhil or for doing any kind of research paper, we are going to follow this particular steps. Again, I'm not going in detail. You'll be learning in your syllabus also. So first is preliminary section, which is also called an introduction section, where your title of your topic and acknowledgement for your guide and for anybody who has helped you directly or indirectly, you're going to give thanks. And table of content. So whatever the content that you included, that you're going to express in a tabular format. List of table, you'll be using the tabular format for expressing your data, that you're going to give information. List of figure, you'll be using some pie chart, bar chart, you're going to disclose that also. And abstract is very important. So where you're going to give the whole summary of about your research. Next is main body, introduction about your topic and why you are doing that particular topic. There are several topics, but why you're choosing that particular topic. You are going to tell about importance and statement of a problem, purpose and hypothesis. This you're going to learn, and limitation. So what are the limitations that you face for doing your research? Next is literature review, very, very important. Okay, this is the main step where your title will get finalized. Okay. Next is design of a study. Even this we have discussed. Okay. Next is analysis of data. Even this we are going to discuss. Even this we are going to discuss. A reference section. So if you give references or whatever the information that you have used, directly or indirectly, that you are going to put it in a reference. Okay. If you put a reference, if you're copying something and if you're giving reference, okay, then it is a ethics. That is an ethical way. Okay, no plagiarism. So it is not covered under plagiarism. Whenever you're giving some references for any kind of data that you have copied directly or indirectly. Okay, that is about reference. We will go with the main topic now, hypothesis. Okay, in simple, for example, it's our Indian psychology. We are very good in prediction. Okay, so by just seeing a weather, there are many people that predict, yes, today definitely it is going to rain. Okay, some people say, no, as per my prediction, today it's not going to rain. Or you might be knowing about astrology. They are going to predict about your future. Okay, it may be true or it may be wrong. Okay, that is called an hypothesis. It's nothing but tentative assumption or testable prediction. It is also called as guesswork. You are just guessing whether the rain will come or not. Okay, so it's called as hypothesis. So when you're guessing, there will be two types of guess. One is positive guess, one is negative guess. So one way you're telling there will be no rain today, it is a negative. Okay, that negative statement is called as null hypothesis. Okay, whenever you are expressing your assumption in negative way, it is called as null hypothesis. You can see the meaning here. It's the base of a study signifying there is no difference between two phenomena. Example, I'll go with the second example, which is the app for your understanding. There is no relationship between effect of advertisement on sales. Okay, so if you are increasing sales, if you're increasing an advertisement, whether the sales is increasing or not. So in null hypothesis, as we discussed, it should be negative. They're telling that there is no relationship between advertisement or sales. Okay, very good example. So next is alternative. So it is a positive statement. Yes, today it is going to rain. Okay, at any cost, my prediction will never go wrong. But today it is going to rain for today at particular time. Okay, you are giving a positive statement. That is called as alternate hypothesis. To take the same example, okay, for advertisement and sales, so I'm giving an assumption saying that there is a relationship between advertisement and sales. So whenever you're increasing advertisement, obviously your sales is also getting increasing. Okay, this is a two important types of hypothesis that majority of researchers will be used in their research study. So I hope it is clear. Null hypothesis means negative statement and alternative means positive statement. And in the research, this is the sign we are going to use in order to indicate null hypothesis, that is HO, and for alternative we are going to use H1. Okay, this is about hypothesis. Again, there are different types of hypothesis also. Simple hypothesis, where you'll take only two variables like advertisement and sales. So whenever there is only two variables included in your assumption, it is called as simple hypothesis. Next is complex hypothesis. Whenever you take two or more variables for your study. For example, there is a relationship between sales, okay, advertisement, and the company management style, okay, and also the demand for products. Whenever you're testing two or more variable together, it is called as complex hypothesis. Complex means difficult hypothesis. Next is associative hypothesis. Okay, here the change in one variable is going to change in another variable. Okay, whenever you're increasing a advertisement, your sales is also getting increasing. Okay, so whenever you're attending all the lectures, okay, your performance is also getting increased. Okay, so whenever you take the good precaution about your health, so obviously the getting affected by COVID will get increased if you take all precautions. Okay, so that is about associative, where we are going to study the change in one variable is going to affect on another variable. Next is causal hypothesis. Okay, it says about the cause and effect relationship. Okay, this is simple the meaning of hypothesis. Okay, very important. Okay, for this particular slide, I'll just give you guidance now, but we are going to learn practically how this hypothesis will work in our research also. So as of now, you can just remember the type 1 error. It means reject the null hypothesis when it is true. Okay, you are rejecting null hypothesis. Null means negative statement when it is true. It is called as type 1 error. Okay, type 2 error, accept the null hypothesis. Okay, you're accepting null hypothesis, but it is a false. You got a different answer, but you're accepting this. Okay, we are going to discuss this through practical. Okay, and as you know, for any kind of assumption, there will be some assumption like 95% my assumption will work, or 90% my assumption will work. No, I am 99% sure about my assumption. So that is called as level of significance. Level of significance means, okay, so you are telling 95% you're confident, right? It means that there is a chance of 5% error. Okay, if you're telling that 99% I'll win this game, okay, 1% will be chances of loss. Okay, that is called a level of significance. It can be 5% or 1%. Okay, what is this 5%? 95% is your confidence level. Okay, it means that 5% you're having a doubt. Okay, you are 1%, I mean 99% you're confident, so 1% you have a doubt. Okay, whatever the doubt you're having, it is called a level of significance. And to what level you're confident, that is called as level of confidence. I'm 95% confident, I'm 99% confident. So as it is an assumption, it cannot be 100% true. Okay, there will be percentage of error also. Okay, this is about some of the basics about type 1 error and type 2 error. We came to a very important topic. So now I want you to give full attention. Okay, but in reality, whatever the statistical test I'm teaching today, okay, so that we won't do practically. Okay, in the real life we won't do, because it's a software. Okay, there's a software called as SPSS, our software. Okay, by using those software, we are going to run all the statistical tools. Okay, same like your accounts. Okay, accounts we are learning theoretically and practically, but in the real world, okay, there's a software, Tally software. Okay, same way, whatever we are learning now, that can be run through software. Okay, that is SPSS software. Okay, if you want to learn about that also, you can just request your concerned person. We can plan for that also if you are interested. Okay, so hypothesis, there are two types of hypothesis, parametric test and non-parametric test. Okay, for you, if in your syllabus, they given only few tests, that is t-test, z-test, f-test, and chi-square and ANOVA. Okay, we are not going to discuss each and everything. Okay, we are going to stick on to the topic which is assigned to me. Okay, so as of now, you can just remember parametric test means normal probability. Okay, let me show what exactly it is. So you can see here, this a word called as skewness. Okay, skewness means, so whatever the sample you have collected, it should be like this figure. It should be normally distributed. Okay, normally distributed. Ma'am, what is the meaning of normally distributed? It means your mean, median, and mode should be equal. Okay, for example, mean is 50, median is 50, and mode is 50. So whenever your mean, median, mode are equal, it is called as normal distribution. Okay, a good sample should be normally distributed. Okay, so whenever your samples are normally distributed, we are going to apply this parametric test. Clear? I hope you are understanding. So normal distribution means whenever the mean, mode, and medians are equal, like mean is 50, median is 50, and mode is also 50, then I'm going to apply parametric test. Okay, so in your syllabus, it is given only t-test, z-test, and ANOVA and f-test. And in non-parametric test, it is only chi-square. Okay, I'm going to discuss that. So again, same like that. So whenever your distribution is normally distributed, it's not normally distributed, it is called as asymmetric distribution. Okay, example, you can see here, you can see the picture here. It is not looks like bell shape. This shape is called as bell shape. You can see the difference here. Okay, it is, you can see this side, it is Q. Okay, it is not proper figure. Okay, it is called as positive skew. Okay, and you can see in the next one, negative, you can see here the skewness is here. Okay, so these two are called as asymmetric distribution. Okay, you can see your positive skewness and negative skewness. So together we call it as asymmetric distribution. So whenever, what exactly the positive skewness means? When your mean is greater than median and mode. Okay, your mean is 100, median is 50, and mode is 10. Okay, as all are not same, it is called as positive skewness. Okay, same way negative skewness, when mode is greater than median and mean, it is called as negative skewness. Okay, in simple, you can just remember. So all this in detail, it's not necessary at this stage. So you can just remember. So you can see the meaning of skewness is nothing but lack of symmetry. Lack of symmetry means it's about the shape. You can see here, in simple, it tells about the shape of frequency curve. Okay, this shape is called as skewness. Okay, if it is normally distributed means where your mean, mode, and median are same. It is called as normal distribution. Okay, if it is not equal, if mean, median, mode is not equal, it is called as asymmetric distribution. Okay, so whenever your samples are normally distributed, bell shape, we are going to apply parametric test. Okay, whenever your sample is not normally distributed, that is when mean and mode and median is not equal, they are going to apply the non-parametric test. I hope it is very clear now. Fine, so we'll go with the next content. Yes, so the main picture starts now. So till now we have just heard about the trailers, very interesting trailers. So now we are going to discuss about the main content of your today's webinar. Okay, that is about chi-square. Okay, I'm not going in detail. Okay, I want to cover more of practical compared to theory. Okay, so chi-square, as you already seen in that picture, it is it is non-parametric. Just a typing error. I'm so sorry. It's a non-parametric test. So as you already know, non-parametric test means, okay, where the samples are not normally distributed. It is not in the bell-shaped curve. Okay, so when we are going to apply this chi-square test, it means, okay, whenever your sample is more than 50. Okay, for example, your sample is 100 or 200 or 300. Okay, then only we are going to apply this chi-square test. Okay, it is a non-parametric test, and degree of freedom, this is very, very important for exam. Okay, C minus 1, C means column minus 1 into R means row minus 1. Okay, kindly note down this. So after this session, you'll be having some MCQ also. I've taken only 5 MCQ. One MCQ will be based on this. Okay, so calculate the degree of freedom of chi-square from the given figures. They're giving some figures. You need to write column -1, row -1. You'll get the answer. So simple. Okay, so your and very important is, so this chi-square test is going to give a benefit whether your samples are goodness of fit or not. So you can see the meaning here, which determine whether the particular distribution fits the observed data or not. Okay, whatever the expected data and observed data, whether they are matched together or not. So that will be studied under this test. So I'll explain the practical so that you'll understand more compared to theory. Okay, so as of now, I want you to remember the chi-square is non-parametric test, and this test has been introduced by Carl Pearson. Is the name of a person who has introduced this test, and also the chi-square will be applicable whenever sample is more than 50, and also the degree of freedom C-1, column -1 into row -1, and also the chi-square is also called as goodness of fit. So these 4 points I want you to remember. So we'll see the practical. I hope the Word file is visible for you. Can anyone just drop a chat box message? Is Word file visible? Fine. Thank you. So chi-square. So in a COVID pandemic campaign in India, COVID vaccine was administered to 500 people out of population of 2,000. The number of fever cases is shown below. Okay, after giving the COVID vaccine and without giving COVID vaccine, so how many people got fever and how many people not got fever? That's a study. Okay, you can see here the fever, it is 20 in case of vaccine, and non-vaccine is 100, total is 120. And again, no fever after taking vaccine, it is 480. And after not taking vaccine, the people who didn't got fever, it is 1,400. Total is 1,880. And you need to add up this way: 20 plus 480 is 500, 100 plus 1,400 is 1,500, and 120 plus 1,880 is 2,000. This is just a question. And as we already seen the formula, this is the formula. O means observed, and E means expected, and again divided by expected. Okay, you can see the hypothesis here. Okay, as we already discussed, hypothesis, null hypothesis should be negative. You can see here, vaccine is not affected. Vaccine is not effective in reducing COVID. It's a negative statement. Alternative should be positive, right? You can see the positive statement.
Hello, ma'am.
Vaccine is effective.
Hello, ma'am. The new slide in which you are explaining it is not visible.
The word file is not visible. Sorry.
Yeah, 23rd is only visible. 24th is not visible.
One second.
Yeah, ma'am.
Is it visible now? The word file?
Yes, ma'am. Yes.
Yes, I'm so sorry I didn't give an attention. Okay, so this is an example with respect to whether after taking vaccine, whether people got fever or fever got reduced or not. Okay, that is about a study we are going to take up here. And as we already studied about the hypothesis, null means it should be negative statement, effective in reducing COVID. Okay, it's a negative statement. Again, alternative means positive, vaccine is effective in reducing a COVID. Okay, so this is about hypothesis that we need to frame. That is the first step. Second is you need to write a formula. This is a formula. O means observed, E means expected, divided by expected, O square. Okay, first we need to calculate here some of the basic things here. Okay, you can just observe. It's very interesting actually. So if you focus a bit more, okay, it is very interesting. Okay, first I need to make some calculation. Okay, vaccine fever. You can see here this is vaccine. Okay, and this is fever. Okay, you need to take total here 500 divided by 120. Total is 2,000. So repeat once again. Vaccine ka total 500 and fever ka total is 120. Okay, together of the whole column, the total is 2,000. That is the first step. 500 divided by 120. Sorry, into 120 divided by 2,000. Repeat once again. 500 and the total of fever divided by 2,000. Okay, same way you need to do for non-vaccine fever. That is 1,500 into 120 divided by 2,000. You can see the same thing I have written here. 1,500 into 120 divided by 2,000. Now this column is done. Fever column is done. Go with the no fever. Vaccine, no fever. It means 500 divided by this total. Okay, for 500 into 1,880 divided by 2,000. Same way for non-vaccine, 1,500 into 1880 divided by 2000. You can see the solution what we given here. Same thing. Okay, the total, the row total into column total divided by the whole table total. Okay, you can have a look once you get free. Okay, this is about the calculation of first step. So after doing this, we are going to the normal. There's a shortcut also. Okay, this shortcut is the first thing we need to calculate by applying a formula. So the first step is this step. 500 into 120 divided by 2000, you'll get some value, that is you'll get 30. You'll get 30. So if you get one value, rest you can do shortcut method. So what is the shortcut? You can see your this total 120, okay, minus this value, you'll get 90. Shortcut, without doing any steps, you can just do the calculation. Okay, same way here also. It is 500, this total minus this total. Okay, you'll get this total 470. And this green one is already the question. Okay, the rest of the part without color, it is we are calculating. And same way here, 1500. Okay, minus 90, you'll get 1410. It's a shortcut method. Okay, you can do the normal method or you can apply the shortcut method also. Okay, this is just a working note. Your actual the question, your solution starts. Okay, so observed value means whatever it is given in the question. Okay, in the question are given 20, 100, and 480 and 1400. And this is the value that you calculated. You can see a 90, 30, 90, 470, 1410. Okay, same thing you have taken here. Next is O minus E. Okay, observed minus expected. Just you need to minus these two, O and expected. 20 minus 30 plus 10, 100 minus 90 plus 10. Again 480 minus 470, 10. And again last one is also minus 10. Okay, next you need to double this. Okay, 100 into 100 you'll get, 10 into 10 you'll get 100. Same way you need to double all these columns, you'll get these values. Okay, after this, so this divided by expected. Okay, it is 100 divided by 30, 100 divided by 90, and 100 divided by 470, and again 100 divided by 1410, you'll get this column. Okay, so after getting this column, just make a total of this, you'll get 4.72. This is your chi-square answer. Okay, now we are going to learn how to analyze this data and how to give a conclusion. Okay, so here you can see here the chi-square answer is 4.72. This you have understood. Okay, and we need to do this degree of freedom. This I told you to remember. C minus 1, R minus 1. Okay, rows is also 2, column is also 2. Okay, let me show that. See here, you should not consider this total column, and also you should not consider this column also. It is only this two column, the actual figures column. Okay, so it is 2. Okay, so 2 minus 1, and row is also 2 minus 1. So when you minus this, you'll get 1 into 1. So the total answer is 1. Okay, so you, afterwards, so by using this degree of freedom, there's a chart. Okay, so that will be available in every textbook of your statistics. In the last pages, they'll be giving a table value of different tests, like a table value for T, table value for Z. They'll be giving every table value in the statistical book in the last pages. Okay, as a reference, I've already taken this number. So 5% significance I'm testing here. It means that I'm 95% confident that the vaccine is working for reducing a COVID. Okay, I'm 95% sure. It means that 5% I'm having a doubt. Okay, so if the 5% of one is, this is a table value, this you'll get in some chart in the statistic last pages, you'll be getting this value. So it is 3.84. So now we need to compare whether your answer is more than or less than the table value. You can see here the table value is 3.84 and your answer is 4.72, which is more. Okay, the table value is less and your calculated value is more here. So here you can see here, therefore the null hypothesis is rejected. So whenever your answer is more than the table value, we need to reject the null hypothesis. Null hypothesis means negative statement. What was the negative statement for this question? The vaccine is not effective for reducing a fever or reducing a COVID. Okay, here we are going to reject the null hypothesis. It means that we are going to accept the null hypothesis. What was an alternate hypothesis? It means it says about the positive. Okay, the vaccine is going to reduce COVID. Okay, so I think you have understood. So whenever the table value is less than the calculated value, we are going to reject the null hypothesis. Okay, you can see here the table value is 3.84 and your answer is 4.72. Okay, the table value is less than the your answer. Okay, so in that case, we are going to reject the null hypothesis. It means that I am rejecting a negative statement. I am accepting a alternative statement. I mean the positive statement. Okay, this is a way of giving a conclusion. Okay, hence vaccine is useful in reducing the COVID cases. So as we get the positive statement, so we are going to support for alternative hypothesis. Alternative hypothesis means positive statement. Okay, so this is about the chi-square. Again, we'll go back for our PPT. I think PPT is visible for you.
No, not still.
So for all the tests, I'll be giving one example because of shortage of time. Actually, it is a practical, so it needs some more number of time, but I'll try to manage. Okay, one example I've given in a PPT also for your reference. You can try out whenever you're free. So we'll go with the next test, t-test. Very, very important. So t-test is applicable only when your sample size is 30. Okay, I have taken only 20 students as my sample for my study. So in that case, as 20 is less than 30, so whenever the sample is less than 30, I'm going to apply this t-test. And t-test is parametric test. And also remember, this t-test was given by William Gosset. Okay, so the name of a person was introduced. And degree of freedom is n-1. N means total -1, that is your degree of freedom. This degree of freedom will be used for seeing the table value from your statistic book. Okay, this is about the t-test. So in simple, just remember, it is given by William Gosset in the year 1908, and it's also called a student t-test. And this t-test will be applicable only whenever sample size is less than 30. Okay, so this is the theory. Okay, let me cover some practical. I hope screen is visible for you. The word file.
Yes, it's visible.
Yes. See the t-test now. 8 individuals selected random from the population and their weights are found to be kgs 50, 52, 52.5, 53, 55, 56, 56, 57.5. Okay, so the sample size is only 8. Okay, what was the condition of applying t-test? It should be less than 30. So again, it is 8, which is less than 30. Okay, so now we are going to form the hypothesis. The first hypothesis should be negative, that is null. You can see here the student weight is not equal to 55. Okay, not means negative. Alternative is the student weight is equal to 55 kgs. So I'm giving positive statement. So now we are going to apply the formula. Okay, see here. So this is just a serial number just for your reference. Okay, this is the x which is given in your in this question. We are just copying down same thing. And you need to calculate the mean. I think you know about basics about statistics. So mean means total divided by number of items. So when you make the total of x, you'll get 432 divided by number of item 8, you'll get 54. Okay, now you start minusing this x minus x bar. 50 minus 54, you'll get -4. The same way you need to minus all these figure from mean. So you'll get this value. Okay, then in order to get the last column, you need to double this. 4 into 4, 16, 2 into 2, it is 4. 1.5 into 1.5, 2.25, 1 into 1, 1, 1 is to 1, 1, 2 into 2, 4, 2 into 4, and 3.5 into 3.5, you get 12.25. So the answer is 44.50. Okay, so now we are going to apply the main formula. This is the formula. This is the main formula. Mean minus population mean divided by S means standard deviation divided by n. N means number of observation. Okay, so in order to do this main formula, we want to calculate this. Yes, S stands for standard deviation. So formula for standard deviation is this. Okay, so you can just take a total of this 44.50 and divided by number of item. Okay, number of item is n minus 1. Okay, n stands for 8. Minus 1 is a formula. So 8 minus 1, you'll get 7. Okay, so put the root and you'll get an answer of 2.50. 52. It's the answer for yes. S stands for standard deviation. Now apply the main formula for t-test. Okay, this is the main formula. This is the mean. Mean is nothing but 54 kg that we got the answer. And this 55 it is one question. Okay, let me show that question. See here, whether mean weight of a population is 55 kg. This is called as population mean. Okay, 54 we got the answer by doing mean, and 55 it is given in the question, and this 8 is nothing but number of observation. And 2.52 we got from the previous formula. Okay, substitute the values and find the answer, you will get 1.12. Okay, this 1.12 it is called as calculated value. Calculated value. Okay, now apply the degree of freedom n minus 1. So n means number of item 8 minus 1 you will get 7. Okay, so refer that table value from the statistical book. Okay, you will get 2.365. Okay, now we need to compare. Okay, you can see here the table value is more and your calculated value is less here. Okay, in that case, we are going to accept the null hypothesis. Okay, in the previous question, we have rejected because the table value was more than the calculated value. Okay, here it is, the calculated value is less and your table value is more here. You can see the conclusion here. 1.12, which is less than 2.365, therefore null hypothesis accepted. Okay, this is the conclusion. This is the way of doing your t-test. Okay, we'll go with one more test now. If you want me to repeat once again, you can ask the question in the chat box. Okay, so now we have done with t-test. We have done with the t-test. Now next we'll go with the next test here. Yes, next is z-test. Okay, so z-test is applicable only when sample size is more than 30. More than 30. Okay, and this is given by Fisher. Okay, even the chi-square will be applicable for more than 30, but chi-square is non-parametric test. Non-parametric test means where the distribution is not normally distributed. Okay, so that is a different category. Okay, so this is a parametric test. Okay, here also the sample is more than 30, and this is about the formula. And also you need to remember it is given by Ronald Fisher. This is the name of a person who has given this test. So it is Ronald Fisher, and z-test is applicable only when sample size is more than 30. And z-test is parametric test. It means that the samples are normally distributed. So normally distributed means the mean, mode, and medians are equal. Okay, this is about theory. We'll go with the practical. So I'll be sharing this Word file with you also. You can just listen to the lecture, no need to write. I'll be sharing both the documents with you. So next is z-test. This is a very small test here. We can understand within 2 or 3 minutes. A random sample of 400 male students. So 400 means more than 30. Condition is satisfied. Given average weight of 55 kg, can we say that sample comes from a population which means 58 kg with a variance of 9 kgs? Okay, so directly we can apply the formula because everything they are given clearly. And hypothesis we need to form. So null means negative. Average weight of student is not equal to 58 kgs. And alternative is average weight of student is equal to 58 kgs. I think this is very clear. So now we need to apply the formula. Okay, mean is given directly. It is 55. You can see here. And average mean is 55 kg. So we have taken 58. And population mean is also given 58. You can see here from the population with a mean of 58. Okay, so then as per formula, it is n root. N means number of observation. Number of observation is 400. Put a root for that. Divided by 3. What is this 3? Okay, 9. This is a variance. Okay, you can see here standard deviation means this value. Okay, variance means the standard deviation square is nothing but variance. Okay, instead of giving standard deviation, they given a variance. Okay, you need to just remove the square here. Okay, so 9 per square root is 3. 3 3s are 9. So here you need to take 3. Okay, substitute the values, you get 20. This is your calculated value. Okay, same way you'll be getting a table value. I have already calculated that. So table value is 2.58. You can see here the table value is less and your calculated is very more here. It is 20. Where is 20? Where is 2.58? Okay, it is very bigger value. So as your calculated value is more than table value, okay, you are going to reject the null hypothesis. Okay, which means that you are going to accept null alternative hypothesis. If you are rejecting something, the opposite should be accepted. Okay, here you are rejecting a null hypothesis. It means that you are accepting alternative hypothesis. Alternative means the positive hypothesis. Okay, what is that hypothesis? Average weight of stone is equal to 58. So simple. Okay, this is about one more test. 2 more tests we have done with the class. Okay, I'll be sharing this file with you. I'll be sharing my number also. So if you want any further clarification, you can drop me a WhatsApp message. We'll go with one more important test. Okay, comparison chart you can look into later on. So it is given by Gosset and Z test given by Fisher and F test is given by Fisher. and t test is applicable when sample is 30, and z test is applicable when sample is more than 30, and f test is applicable when there are two groups of sample. Okay, I think f test we have not discussed. Yes, next is f test, very, very important. So it is also called as variance ratio test. And also remember, this f test is applicable only when two group of samples are given. Okay, I've taken a sample from B division. I've taken sample from A division also. So there are two set of group here. Okay, only in that case, I'm going to apply t-test for comparison purpose. And also remember, it is applicable for small sample test. Sample size should be very less, like less than 30 or less than 40, like that. Okay, so because if it is huge number, I cannot do comparison. Only if it is limited number, I can do comparison. So in that perspective, I'm telling that so f is applicable only for small sample, and this sample is given by Reynolds Fisher, and this test is applicable only when there are two set of data available with you. I think theory is very clear. We'll go with the practical. I hope screen is visible for you. Yes, you can see here. So first condition fulfilled. So there are two set of data, group A and group B, and they're given some values here. We'll put as per the format. So first, we need to write whatever is given in the group A. Okay, and make it total, you get 3.3. Okay, then next we need to calculate the mean. Okay, mean is nothing but total divided by number of items. So your total is 333 divided by number of observation is 9. You can count here, it is 9. So I got 37. So now minus this 18 minus 37, you'll get minus 19. 20 minus 37, you'll get minus 17. 36 minus 37, 36 minus 37, you'll get minus 1. Same way, you need to minus all these value from the mean value. Okay. After this, you need to double this value. So 19 into 19, 361. 17 into 17, 281. 289. Same way, you need to double all these things in order to get this value. So when you make a total, you get 1134. This is for group A. So same way we need to do for group B also. So first take all the values which is given here. Oh, sorry, I've changed the question here. Okay, you can just concentrate on this. So 29, 28, 26, 35, 30, 44, 46. You'll get a total of 238. Okay, 238. And you need to minus all these things from the mean. So 29 minus 34, you'll get minus 5. 28 minus 34, you'll get minus 6. So same way, all z has to be minus with the mean value. Okay, you'll get this value. So this we need to double. So 5 into 5, 25, 6 into 6, 36, 8 into 8, 64, 1 into 1, 1. Same need to double all these things. You'll get this column, make a total, you get 286. So we have done with first step. Now we need to apply the formula. Okay, so this is the formula for S. So as we discussed, first we need to calculate the S here. So directly we need to take this value 1134 divided by degree of freedom. Degree of freedom means n minus 1. So there are 9 numbers. 9 to n is 9. N minus 1, 9 minus 1, you'll get 8. So same thing I've written here. You can see it 1134 divided by 9 minus 1. 9 means number of sample, minus 1 is the formula. So when you substitute the values, you'll get 141.75. Okay, same thing given the bracket also. How to calculate degree of freedom. Okay, this is for group A. Same way do for group B also. So it is a total. It's a total 386 divided by degree of freedom. So there are 7 observation minus 1, you'll get 6. Okay, so it is 64.33. So now we have done with all the calculation. Now we need to apply the main formula. Okay, so this is the main formula of F test. Okay, you need to just take these values. 141.75 divided by 64.33, you'll get 2.203. Okay, this is your calculated value. Okay, and table value I already referred. The table value is 5.60. Okay, you can see your calculated value is less than table value. Table value is more here, it is 5 plus, whereas your calculated value is 2.20. Okay, so in that case, okay, the null hypothesis will be accepted. Okay, so it means that we are rejecting an alternative hypothesis. Okay, even I think it is clear. Okay, so whenever your table value is less than calculated value, we are going to accept the null hypothesis. Okay, if your table value is more than calculated value, we are going to do reverse. We are going to reject the null hypothesis. Okay, this is about F test. This is the last step of your session, ANOVA. It's a bit big, but it is very easy. Okay, so usually all this thing we won't do manually. Even for your syllabus, ANOVA, there is no practical, it's only a theory. Fine, so let me explain this also. 1 second. Just another 5 or 10 minutes. Yes, comparison chart. You can see, I'll be sharing a PPT with you. Okay, ANOVA. Yes, very, very important. So ANOVA is also parametric test. Okay, parametric test means whenever samples are normally distributed means mean, mode, and medians are equal. I think it is very clear. And this test is also given by Fisher, Reynolds A. Fisher. Okay, and it is an extension of t-test and z-test. Okay, t-test means less than 30 and z-test means more than 30. Okay, the expansion of these two tests is called as ANOVA. Simple. Okay, and also remember very small meaning here. ANOVA means analysis of variance. Okay, this test is applicable only when your samples are more than 3 or more than 2. For example, I am comparing BMM, BMS, and CS. Okay, as your sample is 3, you cannot apply Z-test because Z-test applicable, sorry, F-test is applicable only for 2 set of data. Okay, that we have studied in the previous slide. Okay, so there is a limitation of T, Z, and F. Okay, that was the reason ANOVA was introduced. Okay, in ANOVA, you can simultaneously run for 3 data, BMS, BMM, and CS. Wonderful. Okay, so that is about ANOVA. In simple, remember, ANOVA meaning analysis of variance. It is given by Fisher, and this is an extension of t-test and z-test. And ANOVA means whenever samples is more than 2, we are going to ANOVA. Okay, and there are 2 more the extension. This is not needed for you. MANOVA and ANOVA. MANOVA means multivariate analysis of variance, and ANOVA means analysis of covariance. Okay, so this is about the ANOVA. We'll see some practical, quite lengthy, but I'll try to explain a very simple way. This test, even in the textbook, they have not given. Okay, I've just created a question just to make you understand. To assess the significance, let us skip the story, or what story they're telling. We want the data. Okay, as the what was the first condition? The sample should be more than 2. We have 3 data here, A, B, and C. Very clear. Okay, so now we need to calculate. Okay, make a total. Same question I've copied here. Make a total 9, 11, 30, 9 plus 8, you'll get 50. And again, make a total of this, you'll get 55. Make a total of C, you'll get 60. Okay, now I need to do mean. Mean means total divided by number of observation. So total is 50 divided by 5. 5 means number of items. 1, 2, 3, 4, 5. I got 10. Same way, total divided by number of items. So you'll get 11. Same way, total divided by number of items, you'll get 12. Okay, now make a total of all the answer. 10 plus 11 plus 12. Okay, it is 10 plus 11 plus 12. And how many observation? It is 3 observations. So divided by 3 equals 11, you'll get the answer. So whatever the answer you get, 10, 11 plus 12, you need to make a total and divide by number of observation. Number of observation is 3 here. Okay, so it is divided by 3, you'll get 11. So now we have done with the first step. Second step is calculation of SSC. Okay, so within the group and between the group, that's the meaning. So even this is very simple. Okay, so what the answer you got here for A, this is for A and this is for B and this is for C. There are 3 set of data. Okay, for A group we are doing now. So what the answer we got for A, it is 10. What the total answer we got, that is 11. Okay, so minus 10 minus 1, sorry, 10 minus 11, it is 1. Okay, as there are 5 samples, so there are 5 samples here. 1, 2, 3, 4, 5. You need to repeat same thing 5 times, same thing 5 times. Okay, and second column, you need to do the double of your answer. So you are minus 1, minus 1, minus 1, minus 1, minus 1. Double it, you'll get 1. Make it total, you get 5. Same way do for B also. What's the B answer you got? 11. What's the total answer we got? 11. So minus that, you'll get 0. Repeat same thing 5 times because there are 5 observations. And again, make a square of it. Again, you'll get 0. And again, same way do for C also. Okay, C's answer is 12. 12 minus the total answer is 11. Okay, so again, you'll get plus 1. So again, repeat same thing. Do the double, you'll get 1. Make a total, you get 5. Okay, so now you got an answer of 5 plus 0 plus 5. The total is 10. Okay, the answer for SSC is 10. Clear? Simple but lengthy. Okay, so next we need to do SSC. Even this is same like that question. Okay, so this is your the A sample. Okay, 9, 11, 30, 9, and 8. Let me show that. Okay, this is your question. This is your question 9, 11, 13, 9, 8. Same thing I've taken. Okay, minus with A's answer. What is A's answer? 10. Okay, same way we need to do for B also. Okay, B's individual sample minus with B's answer. Okay, next is C. C's individual minus with C's answer. Okay, you can just observe here, it is same. Okay, this is A's numbers and this is A's answer. Okay, you got this value 1, 1, 3, minus 1, minus 2. Double that, you'll get this value, make a total of 16. And again, B, this is a B's answer, B's variable. Minus with B's answer, you'll get last this value 2, 1, 1, 4, 6. Double this, you'll get this value. And again for C, this is C's number 14, 13, 17, 7, 9. And this is C's answer. Okay, you'll get this value, double this, you'll get 64. Okay, so now make a total of all this thing. 16 plus 58 plus 64, you'll get 138. Now we reach to last step. Okay, that is degree of the mean calculation of chi-square. So between the sample SSC we got 10. Okay, the previous answer here SSC we got 10 and SSE we got 138. Okay, just we need to fill the blanks. So 10, 138 and degree of freedom 3 minus 1 you'll get 2. Okay, for second one it is 15 minus 3. Okay, row into column 15 minus 3, 12. Okay, and again this column you have to just divide 10 divided by 2 it is 5. And again 138 divided by 12 it is 11.5. Okay, lastly we have to divide this. So 5 divided by 11.5 we'll get 0.435. So simple. Okay, after this, this is your answer 0.43, 0.435 out the table value which will be in your statistical textbook. So the table value is 3.89. You can just observe your calculated value is less than table value. Okay, in that case, null hypothesis will be accepted. What was the null hypothesis? Null hypothesis, there is no variation in the marks of A, B, C. Okay, so this is about the way of calculation. It is simple but quite lengthy. In reality, we are not going to do in the manual way. We do have statistical package. The software that is called a statistical statistical package for social science, that is SPSS. By using that software, we are going to run all these statistical tests. Okay, so this completes your 95% of your today's content. Let me go with last one topic. I'm sorry if I'm extending more. Okay, this I'll try to explain a very simple way. Okay, so as we studied that 5% is a doubt. Okay, if I'm telling that I'll get 95% good result, okay, it means that 5% having a doubt. Okay, let us assume that I'm not going to teach theoretically. Okay, let me take with an example. Okay, just to make you understand in a very simple way. Okay, so I and my husband, so we have planned and we thought of investing on a share market. Okay, and we know that 95% whatever we are predicting, it will be 100% right. 5% we have a doubt. Okay, if that 5% loss, if both husband and wife is sharing, it is called as two-tailed test. Okay, so 5% half means, so as I told you, husband and wife are sharing losses there. So 5% is the losses, husband will be sharing 2.5 losses and wife will be sharing 2.5 losses. You can see here, this is your bell-shaped normal distribution. You can see line here. Okay, this is for 2.5 loss, this is for 2.5 loss. Okay, whenever your significance level will be divided into two parts, it is called a two-tailed test. So simple. Okay, whenever that error or that loss will be shared, will be distributed in a two angle, it is called a two-tailed test. We can take an example of that husband and wife example. Okay, I am sharing 2.5 expenses and my husband is sharing 2.5 expenses. So whenever the error, it will be distributed in two extreme angle of your normal distribution, it is called a two-tailed test. This is the 2.5 and this is the 2.5. Simple. Okay, if I won't agree, okay, being a wife, I'll take some privilege here. I'll tell my husband, no, I'm not going to bear any expenses. Okay, in that case, it will be one-tailed test. Okay, so your either husband will be bearing, let us assume this is an husband is bearing all 5%, or wife is going to bear expenses or that loss. My husband is telling, no, you have taken a decision, so you need to bear the losses. So obviously his risk is reduced there. So only I am getting a risk here. So it is called as right tail test. This is a right tail and this is a left tail. It means the husband is bearing that losses. Okay, so whenever the 5% will not be distributed equally, it is called as one tail test. Only one tail means only one person is bearing an expenses. Okay, directly 5% I'm going to calculate. Okay, here I'm going to calculate in a two different way, 2.5 and 2.5. Okay, we have seen that statistical tool, right? Okay, where it says about the statistical what, table value 5%, and we have to refer the textbook in order to get that 5% of value. Okay, when you are applying two-tailed test, you need to divide that 5% into 2.5 and 2.5. You need to refer 2.5 separately in your statistical textbook and again 2.5 separately in the textbook. Okay, then you need to add up both and that will give you results. Okay, let us not go in detail, too technical. Okay, in simple. So whenever the loss, whenever the rejection area is accepted equally, it is called as two tail. Okay, both husband and wife is bearing that expenses. Okay, if only one person is bearing an expenses, okay, that is called as one tail test. Okay, either husband or wife. Okay, whatever we did today, all 5 different tests, we have taken directly 5%. Can you tell me whether it is one tail or two tail? Okay, for every example, what we did today for various tests, I have taken 5% directly. What kind of test it is? One tail or two tail? Be quick. Yes, my question is so simple. If it is two tail, I need to take 50% of 5%, 2.5 and 2.5. I'm going to do distribution like this. Okay, 2.5 here and 2.5 here. So I'm taking 2.5 separately. Okay, if I'm taking directly 5%, it is called as one tail test. My question for you it is, okay, in my example of all 5 different tests, we have taken 5% everywhere. Okay, what kind of test it is? One tail or two tail? Any student can answer? You can drop a message in chat box. Very good. It is one tail. The reason is we have taken directly 5%. Okay, whenever we take directly 5%, it is called as two tail test. Okay, here, sorry, it is one tail test. Okay, reason is the whole expenses of 5% will be bared by husband itself. Okay, so again, this is a loss. Okay, that is called a one tail. So directly 5% is called as one tail. Okay, whenever we are taking 50% of that 5% equally, then it is called a two tail. Two means, the whole amount has been divided into 2 years. Okay, husband is bearing 50% and wife is bearing 50%. So it is 2.5 and 2.5. Okay, I got plenty of answers. Very good. Okay, so this ends your the content for today's webinar. Okay, it is my habit or it is my the way of teaching. So whatever I teach, I want some immediate response. I don't want feedback right now. I'll be testing your knowledge by having some MCQ. Okay, you can just give a try. Okay, in a single shot, it's very difficult at two technical point, but you can just give a try, and if possible, you can drop your answers in the chat box. See the first question. Consider the following test. You need to identify among these 4 tests which is a parametric test. Give me the answer now. Put it in the chat box. F test, T test, Z test, and chi-square. I think you know the meaning of parametric. Parametric means where the distributions is normally distributed. It will be in a bell shape. Give me the answer for the first question. What's the right answer? Yes, others. F test, T test, Z test, chi-square test. No, don't get confused. Wow, Shweta ma'am, very good. Any others? Don't get confused. T test, Z test, F test, all are parametric. Whereas chi-square test, it is a non-parametric. Okay, wow. Tanvi also very good. So it is option C is the right answer. 1, 2, and 3. Okay, so I can go back for the main chart and I can just show you for the quick understanding. See here, parametric, T test, Z test, and F test. Whereas in non-parametric, it is chi-square. Okay, in simple, in your syllabus, it is given only 5 tests. Okay, only chi-square is a non-parametric. And the rest 4 tests, T test, F test, and Z, and ANOVA. Everything comes in the parametric. Only 1 test is non-parametric, it is chi-square. Okay, instead of doing hard work, we can do smart work also sometimes. Fine, we'll go with the second question. This is very simple question. Okay, you need to calculate the degree of freedom, okay, for the chi-square. Even this we have discussed. Tell me the answer quickly. What is the answer? If a chi-square test is to be performed on the continuous table with 3 rows and 4 columns, how many degree of freedom should be used? Degree of freedom. If you want, I can just tell the formula n minus 1 into r minus 1. Tell me the answer. Shweta R, very good. Wow. Neha Patil, very good. Shubham, very good. Wow. You are learning so quickly. Yes, it is 6. Okay, n minus 1. N means, sorry, C minus 1. Column minus 1. So 4 minus 1, it is 3. And again, row minus 1. 3 minus 1, it is 2. So 2 into 3, it is 6. Very good. Okay, so we'll go with very simple question. Among the following, choose the most suitable test that can be applied to examine the influence of one factor on different groups. Okay, they're giving an int here, parametric test. So as you know, there's only one non-parametric test. This is a chi-square. So this should not be your answer. Odd man out. You need to just select from these 3 options now. They're given a hint. This question will be related to parametric. So as you know, the chi-square is non-parametric. This is odd one out for your question. You can just remove this. So now select from F, T and Z, which is the most appropriate answer. Even this is easy. Less than 30, more than 30 and 2 groups. That was the shortcut. Wow, very good. Nashira, very good. And one person without name, very good. GCDDT. Yes, very good. Anupriya, very good. It is t-test. So t-test is applicable only when sample size is less, and when there's a 2 set of sample, we are going to apply t-test. What about f-test? Less than 30. Z-test more than 30. So simple. We'll go with one more question. Very simple question. T-test is given by dash. Who has given the t-test? Yes, who has given a t-test? Anyone? Very good. Shweta, very good. Others? Wow, very good. Isha and Neha, very good. So it is GoSet. Okay, GoSet is given t-test, whereas f-test, Z and ANOVA, it is given by Fisher. And Drucker is not a statistician. He is from business management, Peter F. Drucker. And Spearsman related to correlation, which is not there for you. Okay, so this is our answer. Last question. Identify non-parametric tests from the following tests. Quick. It is very simple question. Non-parametric test. Nashira, very good. Non-parametric text. Veta, very good. Very good. GCDDT, very good. Nashira, very good. Yes, perfect. It is chi-square test. Fine. So I'm done with my lecture. I hope within the given schedule time, I've given my best in order to cover everything with precisely and with an example, with the proof, with analysis. I've given my best out of the given time. I hope I've given justification for an opportunity which was given by Pooja ma'am and the principal madam. Okay, so I'll be sharing this PPT along with the Word file with you. Okay, so I'm having lecture now from 12 to 1:40. So I'll be sharing afterwards to Pooja ma'am. Okay, so madam will be sharing with you, and I'm given my number in my PPT also. So if you want any kind of clarification or the further information, you can just connect me with my WhatsApp number.
Thank you,
Thanks
ma'am.
for yes, ma'am. Yes.
Thank you, ma'am. Thank you so much. It was really so informative. So many doubts of which was in between in our mind also got cleared, and you have done such a nice practical. Thank you so much. But for the formal vote of thanks, first I would like to tell all the students that I'm sharing the feedback link in the chat box. Please give feedback, every one of you. Now some people are remain, but I think they are the real research aspirants, so they remain in the session. Very nice of you. Thank you so much. I'm sharing the feedback link. Just click on it. But for the formal vote of thanks, I call upon Nashra Mullah from SYBMS to propose a formal vote of thanks. Nashra.
Yes, ma'am. Ma'am, I'm visible and audible.
Yes, yes.
Good afternoon, everyone. Myself, Nashra Mullah from SYBMS Bharat College. It is such an honor for me to get the opportunity to thank you all on behalf of Bharat College. I extend my gratitude towards our today's resource person, Mrs. Abhilasha N., Assistant Professor, MCC College, Mulund. Thank you so much, ma'am, for such an informative session on research methodology. The subject of research methodology is a total new concept us. Your today's session is very new concept. So today's session was very understandable by your side. Thank you so much, madam. I also extend my thanks to our Raj principal, Dr. Neetu Kapoor, madam, for always being there and encouraging us. IQSC coordinator and staff secretary, Dr. Savita Punjabi, madam, all teaching and non-teaching staff. Thank you all for being part of this activity. I must thank our BMS coordinator, Sandesh Tambe sir, and Pooja Oak madam for organizing such a wonderful session for our students. Lastly, thanking all the students for attending this session. Thank you everyone once again for making it a great success.
Thank you, Nashra. So nice of you, and thank you, Abhilasha madam. Thank you once again. Every one of you, I have posted the feedback link in the chat box. Please fill the feedback immediately. Thank you.
Yes, Pooja ma'am, once again, thank you for a great opportunity to share my knowledge with your students. So I am very much honored. I hope this session was very useful for students. So
Yes,
if you need any kind of further the workshop related to this, so I'm giving an oral promise to you. So I'm committed to my work. So I'll be a part of your the future endeavors also. And I thank sincerely for the principal madam for accepting me for this wonderful session. So once again, thank you, madam. And I
Thank you,
thank
ma'am.
all the students who was very active and were very participative in this session. So thank you, students, and thank you, Pooja ma'am, especially for you. Thank you so much.
Thank you, thank you. Thank you, everyone. And please fill the feedback link. And I declare that the session is over. Thank you, everyone.